gang, we're going to talk a little bit about finding the average rate of change of a function. And just like the difference quotient that we talked about a little bit before, this is a fancy version of slope. I mean, that's really all it is slope. All right, so we're finding the average rate of a function. And this is slope for something that is not a straight line. This is slope for something that curves. Okay, but notice here it is the average rate of change is going to be the change in y over the change in x, and it just means to subtract your y values up top and subtract your x values on the bottom. This is just a version of slope. This is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It says a and b, and don't let that, think of it as x's, two different x's, okay? So two different x's. This is x sub 2 minus x sub 1. We could just absolutely 100% write this like we always have when we talked about slope, okay? We could write this y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Y sub 2 minus y sub 1 is the change in y, and we use this delta symbol to represent change. Your y values changed. How much did they change? Subtract them and you'll know. And x sub 2 minus x sub 1 is the change in x. Delta again. Delta is the symbol for change. So how much do your x's change? Well, subtract them and you'll know. All right, so let's say we have a curve here. And we want to find the slope or the average rate of change. Let's start with from 0 to 2 on the x. Okay, well, what are we going to do? We're going to take the y values and subtract them, and take the x values and subtract them. And errors are marked. So you could plug it in here, but errors are marked here. We know that we've got 0, 1. Our points are 0, 1, and then 2, 5. So I don't even have to substitute anything in. And I'm going to subtract my y values up top. So 5 minus 1 over 2 minus 0, and I get 4 over 2, or an average rate of change of 2. So if I drew the line from 0 to 2, the straight line here, it has an average rate of change of 2, a slope of 2. How about from 1 to 2? Well, this one's going to be a little bit steeper. Now we're going from the point 1, 2 to the point 2, 5. All right, again, subtract your y values up top, 5 minus 2. Subtract your x values on the bottom, 2 minus 1. I end up with 3 over 1, which is 3. So I've got a little bit steeper slope for these 2 points. Notice that it's a curved graph, the blue graph, x squared plus 1 is curved, and so the slope changes along the curve, slope being the steepness of the line. That would be the slope of the secant that is formed. And this, by the way, is like kind of building toward the definitions that will govern us in calculus. So for those of you who continue on in mathematics. All right, so let's suppose that g of x is x squared minus 3x plus 2, and we want to find the rate of change between 1 and 3. All right, let me switch over here to my other Let's close that guy. Let me stop sharing this guy. Let me turn back on this guy. And now let me share that guy. Here we are. Okay, so we are going to find the average rate of change for g of x equaled x squared minus 3x plus 2 from x equal to from 1 to 3. Okay. So these are my x values, 1. I don't know the y values. 1 and 3 are the x values. So I need to find the y values that go along with this. So what's g of 1? Well, g of 1 is pretty easy. That's 1 squared minus 3 times 1 plus 2. That's 1 minus 3 plus 2, which is negative 2 plus 2. G of 1 is 0. G of 1 is 0. Okay. Now we need to find g of 3. All right, g of 3 then is going to be 3 squared minus 3 times 3 plus 2. 3 squared is 9 minus 9 plus 2. G of 3 is 2. All right, so this function curves, but we want to figure out the average rate of change, the average slope from 1 to 3, so from the point 1, 0 to 3, 2. We will subtract our y values up top, subtract our x values on the bottom, we get 2 over 2. We have an average rate of change of 1 at that point, okay? Now, what is the secant line between these two? What is the secant line between these two? All right, well, this is the slope of that secant line. So think about a straight line. We'll use that formula y equals mx plus b. All right, and we have a slope of 1. There is a formula called the slope point formula. So y minus y1 equals mx minus x1, like this. So we can just plug in one of these points here. So we have the point, we have a slope of 1, and we have a point of 1, 0 on this line. So my equation would be y minus the y1, which is 0, equals my slope m1, x minus x of 1, 1. So I end up with y equals 1x minus 1. This would be the equation of what we call the secant line. A secant line is one that kind of mirrors the curved line, the original thing, and will go through these 2 points. All right, now can I show you what I'm talking about here on my graphing calculator? Maybe it'll make a little more sense here. So I am going to graph the original curved function and the secant line that goes in between these 2 points. All right, so here is my original function, x squared minus 3x plus 2. And delete everything else off. And then I'm going to graph the secant line below it, which we said was 1x minus 1. And I'm going to zoom to my standard window. All right, so here's that original function. And then here is the secant line between the points 1, 0 and 3, 2. Okay. Okay, the secant line between the point 1, 0 and 3, 2. You can see where my secant line touches those, and its slope is up 1, right 1, up 1, right 1. So the average rate of change between those 2 points would be positive 1. Okay, this was our original function, and then we came up with the secant line. All righty, so let's stop that share, and let me see if there's anything else I want to show you here on our power. Nope, can't do that. Let's see, is there anything I want to show you? Can't figure it out. All right, I don't think there is, but let's go back here to our PowerPoint and just make sure. And our keyword then, oh yeah, there you go. There's the same graph that I just showed you. Now on your homework, you're going to have some in which you have to talk about intervals, when are your intervals increasing and decreasing. And I thought I'd just show you on this particular one example. Let's see, this one says, when is it increasing? All right, so if we start right here on our graph, we are going down, 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 down until we get to this point. Then we are going up, 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 up until we get to this point. That's increasing. Then we're going down, 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 down until we get to this point. And then we're increasing again until we get to this point. And we're going down, 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 down. And then we start increasing again until we get to this point. Okay. If you're going to write out the parts where you're increasing, remember to do it by the x value. So the x value here is -7. So I am increasing from -7. Interval notation they want. So I start increasing at -7 until I get to -1 on the x. Then I'm going down, so not there, but I start increasing again at 1 on the x, and I increase until I get over here to 3 on the x. So 1 to 3. Then I'm going down again, and I am increasing from 6 to 8. I am not sure if they want a bracket or parentheses by the 8, but you can try both. All righty. Now you know a little bit more about the average rate of change. We know increasing and decreasing. We know how to name these intervals. And so you should be ready for your 1.3 homework. And the key word for 1.3, again, is the word slope, because average rate of change just means the slope of the secant line. All righty, we'll see you later.